English language structure, which impedes English language learning, especially with regards to parts of speech in context. Consequently, we aim to produce a text editor which, when given in English text, highlights its linguistic syntax in an aesthetically pleasing way in order to aid in the visualization of structure. In particular, this will involve tagging inputted text with parts of speech, both at a basic level, for words which can only take on one role, and at a higher level, for ambiguous words where context needs to be taken into consideration. This text editor is further developed to include dictionary definitions and thesaurus suggestions, which appear when a tagged word is clicked on.
Here we can see the text editor GUI. Users can type text directly into the text box, or alternatively, paste in text from other sources. Users are also given the option to save text files and to open new ones. Once the desired text is inputted, the user can click on the tag button, which runs the text through the Viterbi algorithm. You can see here that the text has now been tagged and colored by part of speech, and that each part of speech is represented here by a color. Users can also click on specific words to view dictionary definitions and thesaurus suggestions.
So at a general level, our algorithm splits text into sentences and then each sentence into words. And the Viterbi algorithm runs on each sentence. So in general, the Viterbi algorithm uses probabilities that we've gotten from sample data. You can see some of the probabilities here to compute which part of speech each word should be, just by figuring out the most likely configuration. So the sample data that we included is compiled from the Brown corpus, which is one of essentially the most classic and one of the oldest tagged corpuses that is used for linguistics purposes and computation, and looks something like this. In addition to the Brown corpus, for input we ask the user for a tag set, which is just all the parts of speech that have been used along with their names. And one of the benefits of this, as you can see here, this is a much bigger tag set than you get to see in the GUI, because in another file we ask the user for a list of categories that they actually want to see highlighted. This way, given the category, you get to choose kind of what you want to see. So if you're more interested in, say, the difference between nouns and verbs, you can look at that. Whereas if you just care about different types of nouns, you can also make that distinction. So when we look at probabilities, we essentially care about two main types of probabilities. The first is the transmission probabilities. So we care about, say, a verb is more likely to appear after a noun than a noun is to appear after another noun. And then the probabilities you see right here are the emission probabilities. So for a given word, what types of parts of speech can it be? So one of the kind of aspects of this program is that because we're working off probabilities from a sample set, we're going to be a lot more accurate with common words, such as, say, run or stand, than we are with less common words, such as, say, panda or aardvark.
You can also see that we give dictionary and thesaurus definitions, and the way that we are able to do this is by loading in two different files with the necessary terms, definitions, and terms and lists of terms. These are then inputted into hash maps for constant access of definitions and term lists by term. In our implementation of this project, we also explored the data structures of hash maps for constant access by key, array lists for lists of variable size, arrays for lists of constant size, the Java regex, the Java GUI, learning how to code collaboratively, getting comfortable with coding without guidance and instructions, and learning how to work with large data sets of millions of words. After finishing our algorithm, we trained our part of speech tagger on half of the Brown corpus, then ran the algorithm on the other half, obtaining approximately 84% accuracy from 491,985 of 585,547 words tagged correctly. 84% is quite reasonable given the limitations of our project and is suitable for practical use. The best part of speech taggers today have 95 to 97% accuracy, but they use much more complex versions of the Viterbi algorithm coupled with structural rules in order to achieve such results. Thank you.